which will here is the RAM as well. That should. What's up guys, this is Boozano. This video is going to be about a small, portable, cheap, programmable computer. So what I mean by that is you can code, program, make your own games, apps and things like that. And it's not just amazing, but it is interesting as well. And who doesn't love games and anime? And I know these are your favorites. And there is one more important thing. We're talking about a computer which will have all the basic features like your laptops, desktops, mobile devices, iPads, Macs. And not only this, it's under $50. You can browse the internet, you can connect hardware with this to do basically whatever you want to. And at the same time, you're saving some money, right? And you can use it on a number of simple and complex projects. So I'm talking about a small single board computer. A complete computer on a single circuit board. Raspberry Pi. So here we have a close-up. And I'm quickly going to go through some of the components in here.
So we're going to start with parts of Raspberry Pi, and then we'll move on to connecting accessories, and then we move on to setup and installation. And after that, the most important part, that is the programming with Scratch and Python. And then we're going to talk about physical computing as well. So 1, 2, 3, 4, and 5.
So the IC in here. So this includes the GPU and the CPU. Contains bulk of the Raspberry Pi system. And I know that you guys have studied in school that CPU is like the brain of a computer. So it is the same thing, yes. Nothing has changed. And GPU is there for visual stuff. And this guy here is the RAM. I know you guys know this from your desktop, right? The big slots. But this is just a tiny one. And what does the RAM do? So the RAM holds whatever you're doing. So if you're working in Word, Excel or anything like that, you're doing your schoolwork for example, and if you don't save it and you switch off the system, then most of the things will be gone, right? So that is the RAM, the volatile memory. So it loses its contents when the computer is switched off. But on this side, as you can see, you got things like SD card or your hard disk. They are non-volatile. So that means your hard disk will keep the contents safe, even if you turn off the computer. So hard disk or the memory cards are non-volatile. And this guy on this side is the radio module. Now why this radio module is important? Because it gives computer the ability to connect with wireless devices, Bluetooth and Wi-Fi radio modules. We also got the power management IC in here. Pi needs to run on power, right? And there is a power port actually at the bottom. I will show you guys. This thing right here. You see this? So this is USB Type-C power port. You might have seen this thing in smartphones, tablets. And there are also these two micro HDMI ports. You can see them from the top too. So HDMI high definition multimedia interface. Yes, you are absolutely right, this is bigger on games and TV. And carries audio and video signals. And connects to display devices, TV, projector, computer, monitor or anything like that. And then guess what is this guy in here then? So this guy is 3.5mm AV jack, audio visual jack. And then on this side, these four guys. Universal serial bus ports. USB 2.0 and 3.0. More fast, more quick. And I know you know about this thing. The Ethernet port. You have the RJ45 connector that goes here. And as you can see, there are two tiny LEDs here as well. I forgot to tell you guys one more thing in here. The display serial interface. This one. It's useful for touch display. On the top you can see 40 metal pins. So this is the general purpose input-output header actually. Now what I mean by that is, so that means you can add additional hardware like LEDs, buttons, joysticks, sensors, pulse rate monitors and anything like that. And we got this guy here for connecting to PoE hat. You see these four? So that's an additional power option actually. There are a couple of other things too. So even if you want to measure, for example, the temperature, the humidity. So it really depends what type of hardware actually you're using and what do you want from your projects. And there is one more thing which you guys may need to know. All the files and the software is actually installed and saved on your micro SD card. Yes, this one. So guys, we are not done yet, we are just getting started. Now here is an important question. How will you install an operating system on your Raspberry? No out-of-box software. Now NOOBs is an easy and simple way to install an operating system on your Raspberry Pi. and you will have multiple options in fact. But we are not going in depth in installation, but we will check out Scratch and Python. So let us get started.
Now we are connecting the Raspberry Pi to accessories. In this case, we have here a mouse and a keyboard, and we are using 2.0, obviously because 3.0 is more quick and we may need it later on in this video. The blue ones on the right side do represent the 3.0 ports. So here we are done with 2 connections now, and we are moving towards the third one now. Now the fourth connection in this case is going to be your micro HDMI for display. Now connecting the power supply should be the last step, always. And make sure not to plug in the power adapter at this point, because we're going to insert the micro SD card before this. So you just got to plug in the micro SD card with NOOBs pre-installed in it. So after you switch it on, you got to set it up exactly like a normal desktop. So after I click the next in here, you got to choose location and other similar settings. It's also going to ask for a password at this point. Your display may need some adjustment, so you got to check in. So there is a check mark on the left side, make sure to use it. Now here is an interesting thing about this operating system. It has the games, it has Office and a number of pre-installed apps on it. So it's similar to the desktop or the laptop which you use. So we have the Scratch 2 interface which we will be using later on.
Now talking about programming, we're going to use 2 programming languages. One of them is Scratch and one of them is Python. So Scratch was developed by MIT. So it has these pre-written chunks of code in the form of blocks. That means there is something always going on in the background while you use those blocks. So they have actually simplified the programming a bit. So Scratch is more or less a visual programming language. Now if you're talking about Python, now that is a text-based programming language. Now what I mean by that is you write the code line by line and there are no blocks. And obviously there are pros and cons for both the languages. Scratch is an easy and simple language to start with because you don't have to write a lot. You just have to drag and drop the blocks. So it's a very easy thing. So all you do is you drag the blocks and use it to make your program. Whereas in Python you have to write the entire script. That means complete text. That also means more flexibility. So Python is more flexible than Scratch. So whatever language you choose, you can do a number of things by using any of these languages. A number of projects, a number of physical computing experiments. So now we are going to start with Scratch and then move on to Python.
Now starting with Scratch 2. You guys ready to check this thing out? Excited? Here is it. Just a reminder for you guys that this is block-based programming language. So first we have the stage area. So this is where your character actually moves depending upon the program. Then we have the sprite or the actual character. It's more or less like a thing which actually moves into the stage area. If you want to change your stage including your pictures backgrounds, then use stage controls. So you can load or create sprites. They will appear in the list here. And on the top we got the blocks palette. It is color-coded categories of different types of blocks you could use. So we got sound, data, control, operators, events, and we will be using all of them as we move on. And then we have the blocks, pre-written chunks of program code. Now on this side we have the script area. So you drag and drop the blocks to make your program. So that means most of the time you will be looking at your scripts area and checking it for any errors. So we're going to start with a very simple example where the character says hello. So we'll go into the events category and drag in these 2 blocks as shown.
So as you run the program, the character will say hello. So the next step is sequencing, and we're going to move the sprite 10 steps forward. And now I'm going to click the run on the top, and now you can see the sprite is moving 10 steps forward whenever I click the green icon. Now we're trying to move this 10 steps towards the right side and 10 steps back to left. Now if I click the run, you will see that the sprite doesn't move at all. But actually it does. It moves so quickly that you will be unable to notice it. But it will play the move sound though, so the program doesn't wait for the sound to finish here. But there is something which we can do here to make this process more interesting. So I'm going to change this to 20 steps towards the right side and then 10 steps towards the left, so that it's easy for you to see the change. Now you can see that it moves a total of 10 steps, a net of 10 steps towards the right side. To make it more visible, I'm going to make plus 20 and minus 5 so that it moves a total of 15 steps towards the right side. Now if I'm using plus 5 and minus 20, that means it will be a total of minus 15 towards the left side. Now since these ones are very quick, you don't actually see this moving towards the right side. So what we're going to do is, we're going to put in a wait block in between, so that as it moves towards the right side, it pauses and then it comes back towards the left side. And you can see both the movements. So we go into the control category, into the palette, and we pick up the block. Now you see that it moves 10 steps towards the right side and a pause, and then 10 steps back towards the left side. So all the programs which we have made till now run only once. Now we are going to repeat the whole sequence multiple times. This is known as looping. So this means you don't have to click on the green thing multiple times. I mean the green icon on the top to run the program. Now let us start with the forever loop, where we move 10 steps towards the right side and then 10 steps back with the wait block. So again, go to the blocks palette and then into the control category and pick up forever loop from there. So here we're going to go with plus 10s and it's going to run forever. Now time to bring it back with -15 and +5. So we are using a wait block here too, and a forever loop. Now let us make it more quick by using -25 and +5. Now if we want to keep a limit on the number of loops, then we have to use the repeat block. As in this case, we are repeating the whole sequence 4 times. Now since we are done with this, just drag and throw the left side. Now here is one more interesting thing, the variables. So obviously these variables, they change with time. And they have two main properties. One is the name and one is the value that it stores. And when I'm talking about value, it can be a number, it can be a text, it can be completely empty as well. So that means you will still see it on the screen even if it has 0 value. So if you are on level 1 and then you move on to level 2 or 3, that means all these levels are nothing but variables. And the same applies to the health of the character. When you have 0 health, for example when you're running out of health or your health is 100%, so that health is a variable in there. The same is your speed. And the same applies to the score you have in the game. So since your score changes from 0 to some value, right? So that means it's a variable. Interesting, right? Now for creating a variable, you go into data and then give your variable a name. For example, in this case we are using loops. So this is the variable name. Now you can drag the block which says set variable to 0. So this is the value you're giving to variable, that is 0. Now just to make it more fun, let us use say hello block for 2 seconds. Now in this case these are 2 separate lines. So that means in this case it will only say the text that is hello. Now let's say we wanted to say the value of the variable which we have set to 0. The variable name is loops, right? For that you will drag in the loops into this small block as shown. Now if we start counting from 7 to 16 with an initial value of 7, that means we have to change the values in steps of 1. So we're going to use the repeat loop in this case. And we're also going to use the block change variable by 1, which will be used inside the repeat loop. So we're repeating the whole process 10 times. That means we're counting from 7 to 16. So in this case we started from 7 and then we are going up in increments of +1. So go to the palette area, click on Control, and then grab the block as shown. Now when you're counting from 1 to 10, that means you gotta set the initial value as 1 and then repeat the whole process 10 times so that it counts from 1 to 10. Now talking about operators will let you compare the two values, let it be the numbers or let it be the variables. So you gotta click on the operators category, the green things on the top. So you can see equal to, greater than, less than, or different types in here. So here we're going to repeat until certain conditions are actually met. Now what I mean by that is, if the value of the variable is greater than, equal to, or less than a certain value, then only the loop will continue repeating. So now we are here with the repeat until block. So we are going to repeat it till the value of the variable becomes 10. So we're going to take the equal to operator in this case. And then we go into the data and pick up the variable by the name loops, which we created before this. And now setting the value to 10. So this thing should actually work from 1 to 10. But remember, if you're setting the initial value to 10, then it won't count anything in this case. Now if we want to count from number 10 to number 17, that means we got to repeat until number 18. And we got to start from number 10 as shown. Now let us start with if then block. So if the value of the variable is greater than 5, we are going to say high. Later on we're also going to use low in some cases. Now we are going to move into Python in here. So the first thing which you need to do in here is move towards the programming section as shown, the Thorny Python IDE, So Thorny is an IDE which actually integrates all the tools which you will need actually to write or develop software into a single user interface. Starting from the toolbar on the top, as you can see all the icons in here. Then we have the script area in here. This is where you write actually your program, your code I mean. Now after this we have the direct line to Python interpreter. This is the shell area. Now what it does is whenever you write a code and you press the enter key, it will give you the result. And all the variables which I will make later on in this video will be in this area. Now starting with the shell area, I will be using the print statement. We are going to check out the results. And remember, you got to press the enter key here every time. Now here in the script area, we're going to use the same print statement. Make sure that you run the icon by pressing the green icon on the top when you finish. Now talking about looping in this case, we're starting a loop from number 0 to number 9. That means a total of 10 digits. So here we're using the for loop and we're using I as the counter, which is assigned to the loop, and it starts from 0 and up, a range which never touches 10 since we start from 0 to 9, total of 10 digits. One more thing here is that the colon thing means that the next instruction is into the for loop. So whatever is inside for loop, it will print it multiple times. So now the variables, as already discussed, their value changes with time. Now let us take a very simple example for variables here. Let us ask someone a question. For example, is your name Batman, Superman? And then we wait for the person's response. If the person says my name is Batman, Superman, then we say you're a superhuman. And if a person says my name is not Batman or Superman, and a person says something else, then we just say you're just a human being. So that means in the program, The variable will be the username, and the input text which you get is known as the string. Now Python will do a direct comparison by looking at the variable username if it matches the string. So this equality symbol in here is going to tell the Python to do a direct comparison.
Now there are a couple of things which I have already discussed about the GPIO header before this. So it has these 40 metal pins. So I won't be using all the 40 metal pins. I will be using only some of them. I will try to make the process as simple as I can. So here are some of the important components which we may need in this case. For example, the jumper wires.
So as you can see in here, all the jumper wires.
And then we got these resistors. They control the flow of electric current, right? But these are color coded. Now what does it mean is we measure the resistance in ohms. So there are a total of 4 bands in this. And we start reading from the left side, where we keep 3 bands on the left and 1 band on the right. So in this case the first band is orange, and at the table you can see orange means number 3. And then we move on to the second band, it's again orange. So that means we add one more number, number 3. And then the third band in this case is brown. So we combine the info from all these 3 bands, which gives us 330. The third band is the multiplier. So we had 3 and 3 from the first 2 bands, and then we multiplied it by 10 raised to power 1. So this gives us a total value of the resistance in here, that is 330 ohms. Now in here the fourth band is the golden one, so that is plus minus 5%. So that represents the tolerance. Now here is an important thing. If you want a very cheap resistor, that means the last band should be either gold or silver, because gold is plus minus 5% and silver is 10%. And if you want a very expensive resistor, that should be gray, violet or blue. For example, gray is plus minus 0.5%. Now if there is no fourth band, that means plus minus 20%. So in this case, we have a total resistance of 330 ohms with some tolerance, that is plus minus 5%. So checking out these things was a very simple thing. Now we have something else too, that is the LED. Now if we are talking about LED, it is nothing but an output device. Your output may be high or low, on or off, and this thing will switch on and off depending upon your output. And you can actually make a number of projects using these things. And there is one more thing which we may need in future videos, that is the breadboard. So this thing has all the metal rails inside and saves a lot of wiring. And then we have these cool little things to cool down your Raspberry Pi.
Now this one is interesting. Here we're talking about physical computing. Now what do I mean by that is, here you actually add additional hardware onto the Raspberry Pi. And for this purpose you will need GPIO header actually. That means we need a specific block from the library in here. That is from GPIO extension library. Now after you're done with the library, you just have to drag and drop the blocks just as you have been doing before this. Here we're going to do a quick test where we're going to connect the LED to the Raspberry Pi, and we will keep it in the on state always. So for this we're going to connect the resistor and the LED as shown. Remember here that you have to connect the long leg of the LED, so the long end is positive or anode, through the resistor to 3 volt. whereas the short end of the LED or the negative end or the cathode has to be grounded, as we want the LED to stay in on position here. Later on, we will be using GPIO pin 25 to turn the LED on and off. But here you can see that the LED light is always on, and we haven't used the looping on and off yet. Now in order to switch on and off the LED, what we are going to do is we are going to use this forever loop here, and we are going to set time for the LED to switch on and off. And this time can be variable or the same. But in order to make the process simple, we're going to keep the time same. Later on, we'll also take one example where I'll change the time to approximately 5 seconds in one case. Now here we're going to turn on and off the LED using Python. Now here we will need a couple of things. The first thing is we have to import the LED from GPIO 0 library. We also have to import sleep. This is from time library. And apart from these two things, just to remind you guys, we have used GPIO pin 25. So we're going to use the same thing here in Python while we write the code. So just few lines of code and we are ready to go. So this will run exactly the same way as we used in the scratch, where LED was switching on and off.